Welcome everyone to another fun live stream here, live with this new ULX3S board, much larger FPGA than we previously had, and I hope the audio is fine because capturing for a reason, not with this camera, because I wanted to plug this in. Just one moment, maybe we stop the stream for a second and see how well it even works somewhat. And so as you see here also the HDMI capture, not capture, HDMI output, don't call it HDMI though, of course it's general differential output as seen in the previous videos. So basically a couple of hours worth of time. You see here just the regular stuff of printing. There's some text, some hardware cursor working, basically all the stuff we previously had already working. Let's maybe, because otherwise it's probably slightly boring to not see me instead of this capture. Let's plug this back in again and have stream hopefully working again. So yeah, just the inconvenience of not having here a complete studio. So welcome everyone to this FPGA stream. If you want to know the details here of this fun stuff, and yeah, also given it a proper name and ASCII graphics here, RX32, our project of Commander RX13 goodness here. And so with this FPGA, if you're new to this channel, previously the previous weeks, let's just change here the view to that is what we usually have, our fancy Sun keyboard here that right now I don't have with me. So previous videos, Icebreaker, Ice40, now the amazing people of, probably should have had this handy, EDA, Symbionic, it's probably, Google this quickly, EDA Symbionic, should have memorized this by now, yes, so a symbiotic EDA there, and those fine people there from Vienna have sent us this amazing board, and so this is much larger as previous live streams, 84,000 logic cells, and so I ported all the stuff over for the Icebreaker Ice40 that Eston from 1BitSquared sent to us to have some fun here, YouTube and our education. So the Icebreaker 40 having 5200 logic elements, this one, at least the largest one of those, there are smaller SKUs. And however, this board is quite different. I said this previous video, including this general purpose differential video, general purpose pins. So this means I spent a couple of hours today, probably it was better that we have not done this on the live stream, on porting this code over. This example was already somewhat based, however the whole startup code was different, so startup code was different, so basically I rearranged this PicoSoc project that we reused from Claire from this Pico RV32 fame. And I shuffled quite some stuff around. I already checked with her and sending some stuff upstream also some other day, because the ULX3S is not yet wired here. So all of this is here. I also changed this assembler startup stuff. Previously this was lowercase s, now it's uppercase s for using GCC's preprocessor. So previously we couldn't use preprocessor stuff here. The fine detail of lower and uppercase files, which by the way you could tell me if the audio is okay, that would be amazing. And welcome and good morning and good night everyone. And so quite some stuff if-dev'd out here. The other stuff like Flash, SPI, worker stuff here, so that we have this all in one project. Yesterday live on this More Live channel we already wired this up into the make file. Because the FPGAs are entirely different. The other one was Lattice Ice40, this one is Lattice ECP5, and this ICE40 was also purchased. So not sure the whole history, but at least ICE40 was purchased, I think, from Silicon Blue or something of that sort. Probably we could fact check this. Let us purchase Silicon Blue or something. FPGA, also without typos. Yeah, Silicon Blue for 62 million. That was in 2011. And not sure what this is with ECP, if this was Lattice own, or maybe they didn't want competition. So yeah, maybe ECP5 was Lattice own and they purchased the Silicon Blue, something of that sort anyway. And so yeah, due to this also, although we're using open source tools, the tools are different, and so step by step, just to document here how much work this is. This took me a couple of hours today here before the live stream. And not only the startup code, but the whole SOC here, if you're interested in this sort, because as you see here, the other icebreaker board, we had the PMOD, which had this TMDS transmitter for DVI/HDMI video. And so I had here to change quite some stuff, adding here from the other ULX3S example project the TMDS encoder. So this is now using fake differential TMDS encoding here. And yeah, so quite some changes. Also, yeah, now we run with 50 megahertz. So this is also, yeah, not making this up, 50 megahertz RISC-V goodness with hardware multiplier, so much improved performance. I also changed the startup to output this here. So yeah, quite some timing changes. Also, yeah, also as you hear audio in the morning, I started like a little little exercise in the morning, wired up the audio, and then this just went so well because certainly the audio pins are different and so on. That I thought, yeah, maybe in the evening, let's do the video. The video is here, as you see here, in this diff. Probably in the meantime you learned on this channel here how to read diffs. So previously we had here all this parallel pin output from the icebreaker PMOD for all the going out to the PMOD here at the side of the, by the way, did I focus probably maybe? On the side here of the PMODs on the icebreaker, and now those are here on the general purpose differential interface, positive and negative pairs, and grouped like this. And then as you see, this is just brute force. Also the next step you see to make this, so going forward with this fun project of Commander RX32, because amazing 32-bit goodness in 2020, and RISC-V and modern stuff. To support both boards, I thought I will try to support both boards, the Icebreaker ICE40 and the Lattice ECP5, and call this one RX32, like our RISC-V 32 embedded project enablement toolchain support glue stuff, and have this RX32-little for Icebreaker ICE40 and RX32.big for this much larger configuration with this much fancier stuff. So yeah, I hardwired this in. This is the fun thing of Verilog. Just assign here some different wires. You see previously this was the pin out on the PMODs for the video, blue, and why is there so much blue? Probably, yeah, whatever, does it make sense? Something that sort. Enable vertical sync, horizontal sync, and now not to change all the Verilog code, I just assign this here from video RGB, so just adding here some zeros, because now we have full 8-bit, previously we only had 4-bit, so video R, 4-bit zeros. Of course, theoretically, now that we have so many 84,000 logic cells, we can make this a full true color 16.7 no less million color goodness. And yeah, just you see previously we had here some DDR output buffer doubling from the other example. So now we have copy and pasted here for this ULX3S some 250 megahertz, no less, clock generation for the, again, previously integrated circuit for the HDMI transmitter. Now this general purpose, all our own differentially encoded 8-bit 10 encoding here for DC bias and stuff. And all this stuff, of course, so this, of course, we reuse. I'm not as insane to write this ourselves. So just somewhere here we generate the clock. So this 250 megahertz signal. Then we have here the VGA to DVI transformation instance. Then the TMDS single data, double data fake differential instance. Again, still all of this low-level HDMI implementation. By the way, these modules, I've shown them in the other video, they are not that large actually. And so this getting here the clock red, green, blue, and output positive, negative. And this is actually more or less all. This rest is just a little bit shuffling. What is also, of course, a little bit more code. All of this looks a little bit everything like 1 hour there, 1 hour there, and in total 3 hours are gone. If you're wondering how long all this time takes. So VGA, we of course also, yeah, and by the way, also Intel goodness here of nice redrawing glitches of Xorg in 2020. So next, so we still have quite some stuff to do right now. I have here a dedicated ULX3S Verilog file. This is ATO SOC or ATO SOC, and ideally, so this is their upstream of ULX3S example for the SOC. This is basically a Pico SOC just renamed and with all the stuff deleted. It is after I added audio, so what I added today is audio here. Now we have stereo no less, and we could have SPDIF if we wanted to for true digital audiophile goodness. And so this instance here, for now I just wired this up, so one wire direct stream digital, previous video pulse with modulated highly audiophile audio. And then because this is 4-bit on this board, so I just output this here, assign this to audio L and left and right, the same wire. And here is this audio module, previous videos if you're interested in these details. Then here's also the VGA core, just hard-coded here some, identing white space. Everyone has their own opinion about white space. So changed here previously, here have been this 8 or 10 parallel PMOD pins. Now we have here this 2 times 4-bit or so general purpose differential interface. And ideally, so this is just proof of concept. Ideally, of course, this should be in the module definition so that it's truly reusable. That right now I can run here make ULX3S proc, and ideally it should be so that the same VGA module can be reused for both modules for keeping avoiding code duplication and keeping everything in fine order. And then of course here with some surrounding stuff, including defining here, of course you need to add here the module inputs and outputs, or mostly outputs here, so the UL3S module outputs for the pin constraints on the FPGA. Then here is the outputs for the ATO SOC, and next I will of course make it so that just with some that we reuse here the same Pico SOC, because the icebreaker example we have been working on, of course, is reusing this Pico SOC. So ideally we should reuse a little bit more code and make the VGA code so that we can commit it and share it with you at home, so that we have one VGA core for the icebreaker and the ULX3S. In general, super amazing stuff. Probably we can also rerun this here as we that just changed some white spacing, also some new lines there. So we don't use, this is just, by the way, the basic enablement, right? So unexpected token, also the fun stuff always live on YouTube. 49, what did we do now? ULX3, 49. What have we done? Is it even? No, it's also not the right file. 49. Okay, we typed this on search something. Yeah. And just to show you how many, so the few warnings are normal of brainstorming, and does this together. So this is only the proof of concept. I'm surprised I got this working in one day, and we're busy live streaming. I think so, probably. So I wanted to show you, okay, this is to synthesizing. How many drop frames do we have? A couple of drop frames. So I mostly only wanted to show you how many logic cores we are using. So we are synthesizing this with 50 megahertz, also clocknet something 50. Okay, so this is, anyway, we actually synthesize, this is just the input. However, we are using very little of this resources here. Did I kill this too early, or? Okay, fine, I can also rerun this. We are just using a tiny fraction of this massive 84. So again, we only ported this icebreaker. Also here it is also. Anyway, and yeah, 10%. And this is still with all the memory in FPGA cells or memory. And this is also with a fun fact. So right now we are using less trellis slices here than the previous icebreaker. So maybe somehow these cells are more powerful and implementing a little bit more carry, flip-flop, something logic, something. Because this is now more or less the same design. Actually, no, maybe actually it optimized. No, wait a second, it should be the same. Anyway, maybe slightly more efficient, but for some reason or the other. However, next we will, of course, improve the graphics to have true VGA. Would, by the way, be fun to see Monkey Islands or X-Wing. Would be amazing if the TIE Fighter versus X-Wing stuff would be open source or something. Maybe we implement something similar ourselves just for the fun of it. Would be totally amazing to see this running on this RISC-V stuff in VGA. However, we have a huge task ahead of us. So this is only the basic testing enablement, because next the icebreaker was using the flash, 16 megabit flash, and this example is right now not using the flash. This is why we have only 64K, while the icebreaker, on the icebreaker we were using the total memory 128K. We could do the same here, but that was not the priority for today, because this board has 32 megabyte memory here, 32 megabyte SDRAM there. So this is the next big project. For that we need to write an SDRAM memory controller interface so that we can run from the whopping 32 megabyte. That will be another fun afternoon or weekend project. And then we also need to implement here very low level code to run from the ROM, because right now this code is running from FPGA cell memory only, so we have only 64K. So the next big thing would port the icebreaker code for the SPI in-place execution. I think this is also partially what here this startup code was doing, among other things. Here this also capital S, thought I pressed it, SPI. So here we have startup code, and that is now if dev'd out for ULX3S. And yes, initialize some scratchpad memory and copy sections here. So this was previously interfacing the SPI, and this will be quite error prone to test, most likely best done in simulation anyway. So these two projects, unfortunately a little bit boring for me and for you, because it was working on the icebreaker and I need to, well, at least the SPI diff and the memory controller, yeah, both a little bit, and both of these things will be quite fragile. If something doesn't work, then the CPU doesn't execute properly. So again, probably best done in simulation anyway. But in general, quite some nice progress here. That this is working, and one day I expected this to be much more of a nightmare and error-prone process. So that was a quite nice day project here. I hope you enjoy this as usual. If you are interested in this, leave me in the comments below. Let's see, we have here right now comments. Let's just pop up chat this, that I can zoom this here nicer with this medium high DPI screen stuff. So now Vara writes, Claire Wolf is someone you stumble upon where you least expect happened to him multiple times already. Yeah, of course, Claire from Rock Linux fame, right? So I actually know her since 1998, and certainly looking forward to, actually I've not met her since the Rock Linux T2 forking. Nonetheless, it's much more amazing that nowadays we certainly totally not on his level of all this formal verification and FPGA implementing. Also, this will not be the next project I'm forking from her, because not my main interest, and certainly have better things to do. And yes, certainly totally amazing of all this FPGA implementation fame. However, we will do this low-level stuff. So it's really interesting, and to continue working together, and like renewed with this FPGA stuff. Just messaged her today on Twitter regarding this fun stuff, and so there will be much more amazing cool stuff coming soon in all this updating stuff. So yeah, welcome Christian. Navarro writes, FPGA icebreaker, FPGA is from Silicon Blue originally. Yeah, I knew this, I just wanted, thanks. But from the naming, I knew this, I was just not sure if this was just a subdivision, sub-project name, or I expected already that it was an external company, but yeah. Carlo writes, prefer this Linux or Grub. I prefer Grub. This Linux and Lilo are totally outdated, annoying vintage code. It's not for me. Grub certainly. Oh, by the way, maybe we write our own bootloader, because they are also microkernel, right? So coming next, also our own microkernel stuff. It's just like, this is so much fun that I have it hard. It's like drugs. So probably better not try this at home, because it is addictive, which probably you guessed is why. Well, this channel is not a commercial. Let's maximize clickbaits on, have some fun here in our 20% extra code and otherwise free hobby stuff. So yeah, next steps. Also next I will, so next is again SPI flash stuff, then DDR SDRAM memory controller. Then we have here vast amounts of memory. Then next, improving the graphic core to simply, again, it's working, but now we have so much more memory and everything that now we can implement the full VGA and maybe even SVGA. Let's see how much memory this FPGA has. Also, on this one we can make this stereo. On the icebreaker I said it could easily make it stereo, just I didn't. So this one we can easily make stereo. So many 80,000 logic cells we have left. And then of course a more powerful RISC-V core, maybe in based on Claire's amazing work there. And then also make, so right now the firmware also, yeah, the next thing that needs to be a little bit improved right now, because this also, by the way, how's the audio? Nobody complained, so I hope the audio is fine. So then let's Emacs. Firmware, so the original firmware from Claire, I vastly put here code in for VGA and audio testing and stuff. And because the ULX right now is not running with flash and only 46K, 64K. I have here ULX3S for a test, which is based on this upstream example tutorial code, based also on the same PicoSoC firmware stuff, where today I again implanted this for testing, including this is just a VGM music file and including this fine logo. I hope you enjoy this fine boot graphic thing here. And so next is also reuniting this in one firmware. So like if deving out all the SPI stuff and other stuff, but actually it's probably not even that much left. The biggest thing is SPI and then vast amounts of memory. And then we could write real small games and audio video stuff for RX32 little and big, and including certainly some 3D examples. As usual, I'm surprised not more people leave comments and vote them down below. Other ideas are among higher resolution, of course, in the VGA core stuff. Here, of course, full VGA and like mode X 320 by 640, 240 by 320 by 240. Mode X, the slightly more square pixel mode, and SVGA, but then also theoretically implementing graphic acceleration just for the fun of it, like BitBLT, and maybe even drawing shaded and textured triangles as previous low-level videos, Verge and Voodoo-like, just for the fun of it. And let's see, I'm more concerned about the audio today because it's only 99 drop frames, and that probably was when we were synthesizing the FPGA Verilog code. It's maybe even CPU overload here. I'm more concerned about the audio because usually I have the audio in the camera, but today I plugged it in and out and switched it with HDMI. So I run with the laptop audio in, analog audio in. Let's see, what else do we have going on here? Yeah, Lilo is deprecated, and the last version didn't even compile for me, but yeah, whatever. Slackware still have Lilo, and well, we have theoretically Lilo, but I would not use it for anything. And yeah, Navarro writes, brand memory cannot keep up with people changing the names. Took me here to remember them in the first place. Yeah, no worries. But we are here a professional video broadcasting stuff, so we need to get this details right. So yeah, that's it for this amazing update. I'm certainly pretty satisfied. And next also coming here more virtualization, QEMU, KVM, microkernel stuff. And in the long run, I will replace this firmware code also with, I set this for all the low-level code should probably not be C, and next I will probably, I had this already decades ago. Do I even have it here right now? Let's see if I have it in embedded. No. Maybe in DOS. No. I have from some Hotplug++ replacement from Rock Linux times some embedded STL that is truly only the most minimal. Do I not even have a here? And this is just the very most minimal and just some IO stream stuff, and just to have this code to be a good example and not have all like use more C++ code. And by the way, fun fact, printf is not the most efficient that you probably, if you look into this embedded stuff from Felix from Leitner, from his diet-libc that even prints out like using printf, adding so-and-so 64K of bloat or something. The problem with printf is that printf needs to support all the format goodness, and I implemented this here somewhere for this DOS level code of ours here. And so it's like basically checking is this format, decimal, and so on, and so all the formatting stuff is in there. So if as soon as you call printf, you have all the more or less complete formatting goodness in there. And actually, so there are some other, like Bernstein, what was his name? Bernstein, was it Den or something? C library, DJ, I think DJB, string functions. I think it was from, yeah, also forked here. Yeah, then Bernstein project makes excellent libraries from Dan Bernstein. And so I don't remember this functions particularly, but he also thought like, yeah, even like decades ago, like, yeah, C APIs suck, error prone, insecure. So he has something like from brief memory, like put int or something of string and int, just like from memory. What do they have is some news file. Can you browse it here somewhere? But something of that sort. Of course, this API is also not the most amazing. However, this is the one thing that is not the worst. So if you in C++, although the formatting also in C++ leaves a little bit to desire, a little bit hard to use and stuff. But the one thing that is actually better is that you don't have all the printf stuff. So if you only print like cout or like standard cout and then here hello whatever, you only have the formatting stuff theoretically if you write this STL. I'm not even saying this STL API is the most amazing, unfortunately it's not, but at least in principle some things there are in theory quite good. So that this would be in theory not even, it's like less code, only like specifically compiling some int formatting code here instead of the whole 64k of printf goodness, and maybe even, yeah, something of that sort. I'm again STL, often I need to Google myself like set width and fill and stuff, and some stuff that printf can do you can't even do in STL, some like field filling, and there are some combinations that are not even, probably even still not in 2020 supported unless they recently added it. But just for the example of it, so for our microkernel stuff, I'm not the most comfortable, unfortunately, with Rust. So maybe we do this like embedded C++-ish to avoid like pointer, like trivial pointer off by one and stuff, like just like not formally very, not like different. I mean, Rust code is often also full with unsafe and stuff, but C++, this is also for 20 years. Imagine we could have like an open source Linux-like kernel in C++ that could be amazing, but yeah, time. If I would have a time machine, some DeLorean and flux compensator stuff, then go back in time and instead of 20 years of Linux, like 20 years of my microkernel and C++, it certainly would probably be totally amazing. But yeah, this code that we will be doing, I have this low-level repository of the DOS stuff where we have done Verge Voodoo, Sound Blast and other stuff. I will also soon, so this firmware will not stay forever. This is just the PicoSoc example base. So I will unite this, and the goal is to share the same DOS low-level and microprocessor low-level code, and later even the same microkernel, to have some nano kernel like low-level abstraction of hardware that we can use for DOS, for microprocessors, embedded stuff, and for the full-blown microkernel thing, so that the microkernel is using the same headers of page tables, of other definitions of hardware, IDE and PCI, and so that you can use the same Rosetta code. I proposed it before, like some kind of Rosetta code kind of repository where you can have readable, most minimal readable examples for your low-level vintage, retro, modern embedded stuff, and microkernel and user space based upon this. So this is why this makes sense, that I have so much fun with this FPGAs in RISC-V because it is a plan. So getting into this, and certainly in this day and age, can't help to get here into the leading ecosystem of. I was thinking this already. I already asked one of my best friends in Berlin, where I grew up with, the friend that we teach ourselves programming with. I think I knew more Pascal. I think it was like I knew more Turbo Pascal and he knew Turbo Assembler, and then we changed their knowledge, vice versa. But he is he is working at some other company, and which always like live streaming when people work at other big companies is like, yeah. Also, he's somehow like, yeah, not really like motivated to sit in front of a camera, but maybe we will see. But this is also the long-term goal. So I hope to grow. I always said this, which is also totally amazing, that Piotr from 1-Bit Square and here's this company, Symbiotic, I forgot his name already, Symbiotic IDA or something. Symbiotic EDA or something. Come on. Suit, it's some Symbiotic EDA, probably. Yeah, should remember that. So that's those folks there where Claire also works. Sends this amazing board over. Did not expect that other people who do this professionally find these videos interesting and encouraging and promotion enough that they send this board over. And I always said this from the very beginning. The goal is like, if we maybe eventually reach such a level, not to make underwear promotion Linus Tech Tips videos, but true creator stuff of doing real creative stuff with code, like not only dropping CPUs and rolling over them, but also like writing real new stuff, like low-level video controller implementations and IoT cloud stuff and so on. But so this is the goal. If we, as people, increasingly collaborate here and this channel grows, of course, the bigger the channel grows, the more people are motivated, and the more I can also support people, like pay them and donate. The more you share, like, subscribe, and finance also other projects, like, and invite them and share the profits there of, imagine someday, hopefully 100,000 subscribers or something. That is a long-term goal of having some really truly low-level open source, open hardware, collaborative creator channel here. And I hope you enjoy this enough to share, like, and subscribe, and comment below what you like and dislike and all this fun stuff. What else do we have here? So as usual, some comments scrolled away. Looks great. Amazing that we can easily have our own non-proprietary CPU these days, and I have to keep reminding me. Yeah, I'm also curious. So what would be totally amazing? So there is this VEX RISC-V, which I think is, however, written in VHDL. However, of course, people like Claire also work on the next generation stuff. So really curious to see what we will have next. Right now I'm preferring Verilog, so I'm sticking with Claire's Pico RISC-V. However, what would be totally amazing would be a pipelined one. So if this would be pipelined, would be totally amazing. Also one with MMU and supervisor mode, hopefully coming soon. We will see. And yeah, if your Intel CPU is too buggy, just take your latest and greatest FPGA and write your own and synthesize your own, and totally amazing times to come with this. And Carlos says, are you the only one right there that like some low-level stuff? No, certainly not the only one. Totally not. There are 10,000 of people. I just look no further than to Claire, Piotr, all the other people working on this FPGA and all the kernel, BSD, Linux kernel, and so on. Certainly there are 10,000. It's just like they sit in front of their PC and do their professional server-grade monolithic one address space, single point of failure, monolithic kernel stuff. But totally everyone is invited. I just while we are talking, of course, this is YouTube channel. We get here increasing coverage. So just while we were talking, I saw you already. Someone wrote here with Spark. Yeah, so good evening, sir. By the way, you don't need to call me sir. For us Germans, we don't call each other sir. So if you write to me regarding these YouTube videos, don't call me sir. I recently ordered something just for the joke of this. They wanted the title on a parcel, and I put the sir just for the freaking heck out of it. And my people in the office had a good laugh when a parcel arrived with, "Hey, here's a parcel for you, sir." René Rebe, yeah. fun jokes you do during the day. You have some good few of your YouTube videos, and VRM, Ultra 1060, and so on. Evidence the other day, ever been run successfully on Spark. Greetings from UK. Yeah, greetings back. Not disclosing any personal details. So, has X ever run successfully on Spark 64? Yes, of course, it has run on the Ultra 5. I tested it recently. Even the Ultra 10, no problems. Also the sad fact, what makes me frustrated after a decade with Linux, on the Ultra 10. Wait a second. No, it's not Ultra 10. Ultra 30. On the Ultra 30 with Creator, also previous video, Creator and Elite 3D frame buffer, it had partially hardware accelerated as much as the hardware could accelerate Mesa 3D from David S. Miller, with handwritten visual instruction set, single instructor, multiple data, Spark assembly, and it of course was also removed from Mesa. But back in the day, just some decade ago, or 2005, 15 years ago, Ultra 30 T2 Linux, perfect X with even Mesa for if you wanted to. But yeah, let's see, hardware guy still, so color still not hardware guy. Some code, but can you use C out and C? And you cannot use C out and C, but of course we will compile this as C++. Maybe this is the fun stuff where I recurrently say, so we will then for C out, like the STL stuff. Let's go to the main function. Oops. Of course we will then not compile this as C, but as C++, obviously. With my embedded STL, I will close this the old embedded STL repository. I will close it and merge it here into the new, like, Rosetta code of nano kernel and other low-level fun code repositories. That to have there some super small, most minimal kernel compatible and low-level DOS and firmware. In my opinion, we should probably in this day and age not use C stuff at all. String copy and stuff should be like totally forbidden. It's just buffer over and underruns waiting to happen. And also one fun stuff, in exact image we use for the API. I can also show you exact image codecs. So in exact image, which is open source, you can download there from our stuff. Here's some fine imaging class, and we use here for read and write, we use streams, and the C++ streams are much cooler than C, because in C++ you can fully exchange this. You can have a standard string stream and have some output buffered in memory, like stream some file in memory, like could it even call it RAM disk or RAM file, whatever. But stuff in C, you can't do this. If you have fprintf and you want to do some formatting, you cannot use here some like other kinds of abstraction. For example, in C++, you could even make your own like exact HTTP stream there of HTTP goodness and connect this to some example org test PDF and have this then opened there in some exact image codec, reading this from proxying this fully interchangeable. And this is all the stuff where I really wonder why the freaking heck is still like a whole desktop environment and more written in C when like everything in well, C, yeah, anyway, not the most convenient, totally error prone and not extendable, and yeah, but whatever. And it doesn't even need to be large. I totally agree with avoiding bloat and stuff. Exact image is certainly an example, and now we will also write in microkernel because it is so 2020. Anyway, yeah, that's it mostly for this video. For last thing, I could probably, we have this view, probably plug in here the HDMI cable again and have you admire this amazing amazing output of this here with mouse cursor and everything. I hope you enjoyed this and see how, yeah, also certainly career opportunity doesn't need to be software, can also be hardware. And let's see, what else do we have there? Now writes put S is a good alternative, but it's only important when you have low-level, slow embedded system. How fast is it? What do you mean? How much fast is what? Turbo Pascal war my Carl's mother studied Pascal when was in university. Yeah, actually, Pascal was not that bad. I wouldn't use it. Also, probably as a fun thing is now I can't plug in the camera. It doesn't even HDMI with this cheap Chinese garbage HDMI grabber. But for me, it was in the 90s, growing up with Pascal and even doing assembler. C was kind of a shock. Took a while to get used to, and yeah. But anyway, that's probably a story for another day. And I hope you enjoyed this FPGA goodness with all the even sound. So all of this fun stuff is fully working. And again, now we have enough logic cells left for stereo, for more operators, for higher graphic modes. And yeah, Mr. Bonk just implemented line lapping in his RSM editor, also amazing. And anyway, that's it for this update here on this now 50 megahertz and FPGA. Carlos asks how to buy an FPGA like this. So this here is a little bit hard to come by. You can, if you want to start with the icebreaker, that is also not closest but FPGA, and then so that is that. That you can also buy there. So this is of course 1-bit square, ready to order. This other board here is coming soon. Also, this is again this is wrong. Probably here. And the other board is only available in small quantities here and there. But as I said in the other video, it is also coming to crowd supply sometime soon. ULX3S crowd supply here as per the previous video. And yeah, but this date here is some ETA unknown. And so right now at this university of the right here, this was Zagreb there in Croatia. They sold this for this workshop. And otherwise some small production runs here and there exists. But you see some comparison if you want something else. Now there's of course some official evaluation board and other boards here, multiple of those. But yeah, just Google what you want. I will mostly, yeah, as I said, this crowdfunding stuff is, this is crowd supply is coming soon. But otherwise, if you want a smaller one, then this icebreaker. But yeah, this probably I will probably focus. I will not like get all of them. It makes no sense to spend my time on 10, 20 implementation differentiations. This my retro vintage like system will be based here. This RX32 .little and .big will be based only on the icebreaker and the ULX. It's very theoretically, I asked Eston, so very theoretically this is open hardware, although maybe I should actually, let me restart the camera, 1 second. Yeah, somewhat annoying that you need to restart this freaking Chinese HDMI thing to have another source with audio. So what else did I wanted to say? Theoretically, if they like never manufacture this, very theoretically we could do this. I would not like plan it today because it's their multi-year project, so they work like 3 years or plus minus. But very theoretically, like if we wanted our RX32 based system, we could spin this, like if like at the end of the year they still have not produced it, then. But on the other hand, maybe it's better just to wait and well have our development fun with these boards that we have right now, and otherwise wait for Linux fun and stuff for companies coming with their ATX, mini ITX or something, RISC-V boards, affordable multi-gigahertz stuff that runs Linux maybe. But yeah, that's it for this update that I hope you enjoyed, and then more stuff. And as usual, leave me, I really mean it, to understand what is the most interesting. Also certainly I see if I should make videos that are the most watched, then I need to make some more mainstream content, and tune in for all the next videos and live streams to come.